Hi guys, this is Kushal from ISER Bhopal, and in this video I am going to explain the concept of supervised learning, which is one of the three important paradigms of machine learning. The other two being unsupervised learning and reinforcement learning, which we will try to understand in another video. So before getting into what supervised learning means, we need to first understand why exactly do we need machine learning? Why do all this complicated stuff? Why can't we just, write down equations for a system and solve them to get our answers? So in order to understand that, let's go to the most popular experiment that we do when we read probability theory, which is this coin toss. So the question is, can you exactly predict whether the coin toss will result in heads or tails? So now the important thing to understand is that when this coin is tossed and it is moving through air, it is following the equations given by Newton, which is force equal to mass into acceleration, which is a deterministic equation. So if you could have all the initial conditions with you and solve this equation, you would get the result and hence be able to predict whether the result finally will be head or a tail. However, the problem is that writing these equations is too complicated because there are just too many parameters to be controlled and we don't even know what values those parameters will take. And that is why, despite the underlying process being deterministic, solving these equations becomes extremely challenging. Apart from lack of information about all the parameters and their values, another problem with these equations is that they are often very sensitive to initial conditions. What this means is that if you change the parameter values or the initial conditions even slightly, the output changes by a lot. And in these cases also, it becomes very difficult to solve the equations. And this comes under what is called chaos theory. Because of these reasons, often what we do is to adopt a probabilistic approach. So essentially, if you have a coin and if you want to predict whether the result will be a head or a tail, we can't do so exactly for every single coin toss, but what we can say is what would happen if we toss the coin many number of times. So essentially what you do is that you toss the coin, let's say for example 1000 times, and you count how many times you get heads and how many times you get tails. So instead of saying that at every coin toss whether I will get a head or a tail, what I ask is that what is the probability of getting a head when I toss a coin once? And that is simply given by this ratio, number of heads by number of tosses. Similarly, you can get the probability for tail, which will be equal to the number of tails divided by the total number of tosses. So here it is important to understand that this 1000 number of times that you toss the coin is just an example, and that may not be enough. It may so happen that you have to toss a coin many more number of times till you get a stable, reliable value of this probability. And of course, because our system has only two possibilities, heads or tails, the sum of these two probabilities has to be equal to 1. Because if you toss a coin, it has to be either a head or a tail. There is no other third possibility. So this is a very simple concept which most of us understand. It is often taught in schools. Now let us add a little bit of complication. Let's say what if the coin toss result depends upon other factors like wind speed. So this image that you see on your screen is the distribution of wind speed all across India. The regions marked with red have higher wind speed and other regions, let's say those marked with blue, have a lower wind speed. So if you toss a coin in these different places, will you get the exact same probability or not? I do not know the answer a priori, I am just asking a question. So now let's say that you did this experiment, you took two locations, let's say one was Goa and one was Bhopal. So in Goa, let's say the wind speed was very high, in Bhopal the wind speed was low. You toss this coin n number of times in Goa and n number of times in Bhopal, and out of these number of times you got heads for A1 number of times in Goa and A2 number of times in Bhopal. So now what we would say is that the total probability or the cumulative probability of getting a head in total is equal to total number of heads by total number of tosses which is a1 plus a2 by 2n. However, if you want to know the probability of head, given that the wind speed is high, will be equal to a1 by n, because that was the experiment done at Goa. And similarly, if you want to find the probability for head given low wind speed, that would be a2 by n. So this is what is called conditional probability, because instead of talking of just probability of an event, we are talking of probability of the event given certain conditions. Now this is again fairly straightforward. Now let's make it slightly more complicated. Instead of just asking about the probability of head given high wind speed or low wind speed, suppose if I ask what is the probability of getting a head for a precise value of wind speed. So let's say if I ask what is the probability of head if my wind speed is 114. So how would you estimate that? It is quite difficult. So what you can do is that maybe you can find a place where the wind speed is exactly 114 and then do the coin toss experiment, but that is very, very unlikely to happen. You may find a place with a wind speed of 100 or maybe 135, but those things keep varying a lot. So you will never be able to find a place exactly where the wind speed is exactly what you are looking for. So what do you do now? So what you can do is that you can do this experiment for different wind speeds. So you can go to different areas, or in the same area you can repeat the experiment for different wind speeds and compute what the probability of getting a head is. So let's say you get a graph like this. This is not representative of how a coin actually behaves. This is just a fictional example which I am giving you. Okay. So suppose you did these. Suppose you did this experiment at 5 different places, and these are the experimental results that you got. Now you want to find out what is the probability of getting a head for a slightly different wind speed for which you did not do the experiment. So what you can do in that case is that you can try to fit a curve to these 5 points, and using that you can find out what would be the probability of head for a different wind speed. The problem with this process is that there are different ways of fitting a curve. Especially for a finite number of points, you can fit infinite number of curves to those given points. So now we need to ask which of them is the correct prediction. So here comes the concept of training data and testing data. So let's say these 5 points were a part of our training set, and using these 5 points we did a fitting to our curve. Now we need to use the 6th point to see which of them is the better fit. So in this case we can see that the red line is closer to my point, and hence I can say that my red line is a better fit than the yellow line. In this particular case, as it so happens that instead of drawing a nonlinear curve like this, we can even fit a straight line with a high degree of accuracy. So a straight line is just y equal to mx plus c, and you can do linear regression, and using this method of least squares, you can find out the slope and the intercept of the straight line for a given set of points, and using that you can do your prediction. But sometimes it so happens that the data is such that a straight line fit doesn't quite work. So now I have changed the data points, and if your data looks like this, then a straight line is not really a good answer. So in this case, what do? So here supervised learning comes into play, and essentially what supervised learning does is that it tries to predict this function which connects a set of inputs to a set of output. So in this case, for example, your set of input was wind speed, your set of output was the probability of getting a head, but in general the set of inputs may not just be one, it may be many. Similarly, the set of outputs may not be one, it may again be many, and the number of outputs may not be same as number of inputs. So in this case, we have n number of inputs and m number of outputs, which may be different, which may not be different. So the objective of supervised learning is to predict or estimate this function which connects our input and output. So I have many data points about input and output, but what I do not have is this function connecting them. So now the objective is to figure out this function Approximately, exactly figuring out the function is almost an impossible task for almost all real life applications. But we can predict these, or we can estimate this function approximately using methods of supervised learning, of course given some input and output data points. So this is essentially what supervised learning is all about. There are many ways of doing supervised learning. One of the most popular of them is artificial neural networks, about which we will talk in another video on this channel. But for now, what is important for you is to understand the basic concept of supervised learning, which is, given a set of input and output data points, can you approximate the function which connects them? And this of course has many applications, some of which are on your screen: handwriting and gesture recognition, face and object detection, language processing, speech recognition, spam detection, and many more. Supervised learning has essentially revolutionized the way we interact with the online media and many other things on the internet. Now coming to more details about applications, if we take handwriting and gesture recognition, one obvious application is in the field of healthcare, where, for example, if we could digitize all the prescriptions that doctors write for various diseases, that would create an amazing database which could be searchable and which would really help us in figuring out which medicines work well and which do not. Similarly, in education, if we could again use handwriting recognition, taking online exams and doing stuff like that would become so much more easier. Similarly, in the automotive industry and many other consumer services, handwriting and gesture recognition could be very useful. For example, if we talk of the automotive industries, let's say you are driving a car, and instead of having to press various buttons on the control panel, if you could just make some gestures with your hand and the car would recognize what is it that you're trying to do, driving would become such a nice experience. Or, I should say it would become a much better experience. Coming to face and object detection, of course, this we all know about, surveillance, security have become major issues nowadays. There are these, video cameras placed at almost all public places, and they do try to, recognize various kinds of faces automatically. In traffic management, anomaly detection, and many other areas, face and object detection could be very useful. You see this picture on your screen, which was taken during the 4th Paradigm Conference organized at IISER Bhopal. Now let's say you can, develop a machine learning algorithm which could detect all these faces, find out their websites, download all their publication list, and do some statistical analysis of the kind of researchers who attended this conference. That would be such an amazing service. Imagine just at the click of a button, you would get complete data about all the attendees of a conference. That would be very helpful in many ways. Now coming to some work that we have done at IISER Bhopal on the applications of supervised learning. So we have developed an algorithm for fake news detection. News is essentially supposed to be, noteworthy information about recent events, and this information is supposed to be correct, and it is supposed to be written in a straightforward manner. However, in order to grab TRPs, many news agencies have started presenting opinion pieces as news. Now, if opinion is presented as opinion, that is absolutely fine, because then the reader knows that it is opinion and not news. But if an opinion is presented as news, that is highly problematic, because then the difference between what is information and what is purely my own perspective gets garbled, and that is not a good thing for any society. We have developed an algorithm using supervised learning to detect this kind of fake news, which essentially consists of manipulative writing style. So we are not checking for correctness of information, but only whether the writing style is manipulative or whether it is written in a straightforward manner. Now it may seem that, why is it so important? So, I would like to share with you an important quote by Madeline, which says, "Because to take away a man's freedom of choice, even his freedom to make the wrong choice, is to manipulate him as though he were a puppet and not a person." This is a very crucial, thought which Madeline has shared with us, that, many times what happens is that, some newspapers already have their own biases, even though the newspaper doesn't have, but the journalists, may have their own biases. and because they think that a certain perspective is the right perspective to have, they tend to present their own opinions as factual information, and that is very wrong and should be objected to. So our algorithm detects those tendencies, that if an author is trying to manipulate you through the use of language, our algorithm will be able to help you out and warn you that be careful while reading this article. So in order to know more about our algorithm and to see it in action, please do visit our website fictometer.com. So I hope in this video you have understood the basic concepts of supervised learning. There are many ways by which supervised learning can be implemented. For example, in this particular problem of fake news detection, we have used the concept of logistic regression. Another very popular algorithm of supervised learning is ANN, or what is called artificial neural network. In another video on this channel, we will explain to you what is this concept of artificial neural network. You can find the link in the description box below. Thank you.